Your mission for today is to understand all of the difficult graphing problems for the test. And then tomorrow we'll wrap it all up with another big review. Why? Well, frankly, part of it is because this is a short week for you guys. Friday's your day off. You get lucky you. We have to do conferences. But we're going to do our test on Thursday. It gives us one last day to review. Test on Thursday. All right. This equation, you should be able to tell me by looking at a point and a slope. And I want you to just write it like this. This is not the right answer, but write it like this. Y equals 1/3 x. That would be rise of 1, run of 3, plus 2. That is totally the wrong answer. But we're going to say that this spot right here, I was trying for, that spot right there was 1. And that's weird. I swear the graph paper moved. It used to go through that spot there and that spot there. This was at 1. And that's 1, 2, 3, 4. Okay. Did you catch then that the y-intercept right here was at 1? Therefore, this should have been at 1. Now, you know, some days I swear there's like something in the air that makes kids like more distractible. Like they just want to be on their phone or they want to be somewhere else. Today's one of those days. So fight that, because I know there's people that are not with me right now. Please be with me right now. So you should be writing this equation. Neverman, are you with me? Okay. So I want you to make me the right slope. How much did it rise from this point here? Maybe I'll make them crazy bright green. That point to that point. How much did it go up? How much did it rise? How much did it run? And then you put your slope here. To me, it looks like it went up 1 and over 2. Who had 1/2? Raise your hand if you had 1/2. Okay, awesome. That is right up until now, and now I'm going to shade underneath it. Now it isn't just an equals anymore. If I shade underneath it, that changes the top part of the sign. It's still or equal to because it's a solid line, but I shaded under it. Does that feel like it should be a less than or a greater if I say under? Less than. Less than or equal to. There is your equation. Y is less than or equal to 1/2 x plus 1. All right, I know this is hard to do, and I'm starting with one of the toughest things. Let's see if you could have just graphed it. Everybody write this. Y equals 2/3 x plus 1, and we're going to change it to greater or equal. So you'll shade, hopefully you know which way. Now, I totally get that you don't have graph paper, but there's a way on your iPad to pull up graph paper. If you really want graph paper, take a couple extra clicks, pull up graph paper. Now, I use a program called Explain Everything, and I can tell you in my program how to do it. Can somebody who uses Notability every day tell me a quick way to make graph paper appear on your page? Anybody that's the techie in the room know how to do that? Maybe there is nobody who knows how to do that. All right, I'm going to pause for a second and make it. That's your challenge. All right, so we started at 1. Now I'm going to make my lines be better on my graph. So I'm going to start at 1. I need honesty. Can you see the light blue lines for my graph paper? Can you? Okay, looks like most of you can. Awesome. They're very light, but so that's where I would start because it says 1 is the y-intercept. Then I'm going to rise 2, run 3, rise 2, do, run 3, do, and my new dot will be right there. My first dot was there. My second dot, rose 2, ran 3. I draw a line like this. Do I need to shade? Yes, because it said greater. What does that make you feel like you should shade? What do you think?
Above the line.
Above, that is correct. So shade above it. When would we ever have a dotted line? Yes. If it wasn't equal, you're right. See how this one says greater and it says equal? Then it's a solid line. If it just said greater, dotted line. All right. Here's one where the graph doesn't matter. It's just an equation. Please copy it though. Y minus 8 equals 1/2 x plus 2. Now tons of kids last hour had trouble with the fraction part of this. Please copy what's on the board. The fraction part of this, I know, I can do this in my head. I would change that fraction in my head to what? What decimal? 0.5. Good. But a lot of people have trouble putting that in the calculator. They go 1/2 times 2. And then it messes up the order of operations. So if I were you, just to be safe, I would do that part first, and then I would get the answer and say it's 0.5. And then I'd distribute the 0.5. Now, could I say 1/2 x? Absolutely. That actually looks better because I have my rise and my run. But now this part will be easier. So if you have trouble getting this second part of the distribute done right, get a decimal here. And anybody's calculator can do 0.5 times 2, and it'll be 1. And here I have my y minus 8 equals all that. Then I just have to, well, what? I'm going to add 8 to both sides. Pausing while I'm having kids compare their answer with the kid next to them. 1/2 x plus 9. Raise your hand if you had it right. Okay, awesome. Now, would anything have changed if I changed it to less than or equal to? No, nothing would change. If I graphed it, though, then I'd have to do what? What does this make me do on a graph? Shade. And it's less than, so it would be under. Good. Okay. So that took one that was in what's called point slope and turned it into slope intercept. That's one of the toughest things. You want another toughest thing? For some of you, just finding the slope is like enough. Just find the slope. But for those of you who can, find the slope and then put it into that equation I told you to memorize. Y minus y1 equals m times x minus x1. There's the place for the slope. So once you figure out the slope, it goes here. Once you figure out the point, it'll go there and there. Just make sure you don't mess up the point. It's so often that people put them in and they say, okay, I'm going to use the 1, 2 point. You can do that, but don't put the 1 in the first spot. The 1 is an x. All right, walk me through the steps of finding the slope. Amit. Start with a 4. You know how to do slope? Remember how to do slope?
It's 2.
Okay, can you just tell me what you did, though? It's probably right, but...
I did 4 minus 2.
Over.
3 minus 1.
Awesome. And then 4 minus 2 is 2. Over 3 minus 1 is 2. It is a lot of 2's, but the final answer? 1. Because you got to take the 2 divided by the 2. 2 is definitely in it, but the final answer was 1. All right, so there's my slope of 1. That's where the slope goes. Mr. Lin, can you tell me, which point did you pick to use? The 1, 2, or the 3, 4?
Either is fine.
You're right.
Choose 1.
You're choosing 1 and 2? Awesome. So tell me where to put the 1 and the 2. If we're going to put in 1, 2 into this, where does it go? Do you know where the 1 goes, Mr. Lin?
In the back, the x1.
Yes, and notice how I'm going to have a minus 1 there, even though this is a plus 1. And Khalid, do you know where to put the 2?
The x.
It is, 2 is the y.
Oh, the y.
So in the y. All right, so the 2 goes here. All right, there we go. Now, I should back this out a little bit, sorry. I did some weird setting to my iPad and now it like super zoomed in and I don't know how to undo it, so I will fix it later. All right, so there's my equation. Y minus 2 equals 1 times x minus 1. All right, then last but not least, what about just plain graph it? If I give you this equation, would you please use that graph paper thing again? 3 dots, if you have moved off your graph paper, go for 3 dots, and then it's a template, and then choose grid. And on your graph paper, graph this. You should know where to start, you should know the rise, you should know the run. Damien, where should I start with my first point to graph this thing? At 4. 4 on the what axis? On the y-axis. 1, 2, 3, 4. There's my first dot. Now it's rise and run. But the tricky part is, a lot of kids last hour thought they were both negative. They're not. Only the top is negative. Because you want to do rise first. So we do down 1. Down 1. And then run 3. And your second point would be right there. How many of you did that one right? Awesome. I know you're going to know how to draw the line through this. That's anybody can connect dots. That's easy. Okay. So then the last thing is if I change this to a greater than sign. Notice it's now greater or equal. Notice if it hadn't been equal at all, if it just was a greater than sign, you'd have to use a dotted line, but I didn't want to have to go back and make a dotted line, so I left it as greater or equal. Asen, what does that last step make me do? Shade above. Greater means above. There you go. All right, the only other thing on this is if they just add a little context. And they say, this problem was about you earning money for each hour that you worked. But that wouldn't make much sense in this case because it's going down. You do 1, 2, 3 hours, 4 hours, it's going down, down, down. That doesn't make much sense. Because if you work for 4 hours and you make less and less and less, that doesn't make sense. But this could be a robot's battery. And at the start of the job, at the very beginning, that would be here. It's got a full tank. And let's say that that's 4 kilowatt hours. Batteries are judged by kilowatt hours. So let's say your robot is completely full when you start, and your robot is out there working on your lawn. This is going to happen. It's just a few years from now, not like 2 years. By the time you're my age, there's going to be robots everywhere. No, I know for sure. Because there's 20 different companies that are all making robots right this second. They're all competing to try to be the first one to get a really good usable robot. And when those robots are out working, they'll work. Robots will be able to work for like $4 an hour. Do you get if an employer has a choice and they could pick a robot that might work for $4 an hour, and they might have to pick between that and a human that makes $20 an hour? They're going to be like, I'm going to take 3 robots, and it'll still be cheaper than a human. And I know that's a little scary, but that's what's coming. There's nothing that you can do to stop it because you just, once technology like this is out there, you can't stop it. It's kind of like AI. Now that everybody can use AI, you can go to ChatGPT and you can get it to do amazing things. Nobody's going to be able to stop that. Yes? What do you think?
Would it take people's jobs?
It will take people's jobs, for sure. I know, that's scary. But it's like one of these things like, did it take people's jobs when computers started? Yeah, it did. Because there were some people that got paid just to like add things. Like seriously, there were people who were paid to make spreadsheets that weren't on a computer, they were just on paper. And all of a sudden those people couldn't do that job anymore. But it opened up other jobs. So computers didn't like kill everybody's job, but they killed some people's jobs. So the same thing's going to happen with robots. They're going to kill some people's jobs, but they're also going to open up other jobs. And so like maybe you'll be the guy who's got to be in charge of a fleet of 3 robots that goes out and re-roofs houses. And you're the guy in charge of those 3 robots. All right, so anyways, I just added context to this, and this is your battery life. Do you get how battery life is slowly going down here? Does that make sense? With the robot is working, it's going to burn its battery up. Okay, so then that's called the slope. So when you're asked questions about the slope, please write this down. Slope is rate of change. Slope is the rate of change. So on the test, when we ask you about a real world problem, you'll be looking for the slope. Good. You'll be looking for the slope, and you will be looking for how fast is it changing, because that's what matters here. Well, if we go back to my robot graph, it started with a 4 kilowatt hour battery, and it's now got a lot less. By the end, after it looks like 5-6 hours, it's down to 2 kilowatt hours. The slope, you don't have to like look too far. That's the slope. You're using 1 kilowatt hour every 3 hours. And so actually this is where 6 is. Yeah, 6. That actually makes sense. Okay. So over 6 hours, it used up 2 of the battery. The battery was at 4, and now it's down to 2. So in the context of this problem, it was about using up the battery. And you were using -1 per 3 hours. In a restaurant, do you get that the people that work there have to get paid? They don't just come there for free, right? So they get paid per hour. Do you get that at most jobs, when you get there, just for showing up, they're not going to give you any money just because you showed up. They're going to give you money for each hour you worked. And if I was working at this place, the slope of this line, that's my rate of pay. And this one looks like it goes over 2 and up 2. Hopefully these are 10, 20. And if this was the case, I work 2 hours, I make $20. That's actually pretty bad for nowadays. 2 hours for $20, that's only $10 an hour. That's the rate. That's the slope. Whatever the slope of the line is, figure out the slope. In this case, it's 20 over 2, or could you have said 10 over 1? Yeah. And that's your pay. And it starts at 0, doesn't it? Plus 0. All right, now I get this is complicated, and this might be one of those things that some of you aren't going to get, and that's okay. There's only 1 or 2 questions like this on the whole test. And this would be in the hard section. But what's the rate of pay for this? 20 divided by 2 is $10 per hour. And this would be hours, and this would be money. If you get stuck on today's worksheet on a problem like that, bring me over. I'll walk over and help you. Or you can walk up and ask me. Okay, last little side note. The slope on a problem is 4. What if you wanted to be perpendicular to that? You got it? You are correct. Perpendicular to that would be -1/4. Okay. And what that means is, if I actually had a graph, I got a slope of 4. It's like really steep. It's rising 4, running 1. It's really steep. And then I do a slope that goes the other way so that it will make a right angle. Those two are called perpendicular. They make right angles to each other. And this one has a slope of 4. And this one has a slope of negative, because it's going down, 1/4. Okay, we've done enough review. Tomorrow is the full review day where I cover all the easy stuff and some of the hard stuff. Today was all the hard stuff. So if that felt like really difficult, that's because those are the hard kind of questions on your test. I think of it this way. You get the easy ones right, you'll be at 75. Then you're just going to try to add on 5% for each hard thing you can do. I know for some of you that's like, yeah, I can get that. It's just a slope. I can do that. For others of you that might be intimidating, and it's okay. We're all different people. We're all going for different goals. And here comes your worksheet. And that's all I got for the video for today. The worksheet is a practice of this topic.